Good morning and welcome to DNVGL's webinar on preparing for the storm, minimizing the risk through resilience. This webinar is organized by the Local Government Sustainable Energy Coalition, or LGSEC, in partnership with DNVGL. My name is Grace Kaufman. I am a project associate at the Local Government Commission, serving as the coordinator for LGSEC, and I will be your moderator for this webinar. A quick overview of today's agenda. I will provide a brief intro into LGSEC for those who may not be familiar with us, then onto our feature presentations. Before we get started, I have a few logistical items to go over. Everyone will be muted except for our panelists. Due to the large number of participants, we ask that you type your questions into the question box. Please feel free to submit your questions at any point during the webinar. I will be summarizing those questions during the Q&A portions, which will follow the presentations. At any of the questions we don't get to, we'll ask our presenters to respond to after the webinar, and we will share their responses in a follow-up email. There will be 3 polls throughout the webinar. The polls will appear on the webinar control panel, and the presenters will announce when each poll will be launched. This webinar will also be recorded and made available on our website along with the PowerPoint presentations. As I mentioned, this webinar is being organized by LGSEC, which is a network of local governments and their allies from across California. LGSEC is the entity that represents local governments at regulatory proceedings. Each month, LGSEC provides a comprehensive debrief of regulatory updates for its members. Together, we work to advance energy action and increase local capacity to build community resilience. The Local Government Commission serves as the program administrator for LGSEC. LGSEC is working to expand our strong peer-to-peer network of sustainability practitioners and to formalize mechanisms to exchange knowledge and tools. Through our advocacy and engagement, we are working to bring integrated energy solutions and resources to local governments across the state. If you have any questions or if you're interested in joining LGSEC, please don't hesitate to reach out to me. Now I'm going to hand the mic over to Betty and Lauren, and who will be introducing the presenters. Quick reminder to all participants to please type your questions into the control panel at any point during the presentation.
Great, thank you so much, Grace. Can you hear me?
Yes.
Okay. So we're thrilled to be partnering with LGSEC on this webinar today. It's obviously a very timely topic, preparing for the storm, given the high-profile hurricanes that we've encountered in the last several years. So today, I'm joined by my esteemed colleagues, Lauren Tamor and Cora Gessert, who are experts in their fields of building resilience and carbon-neutral communities. So during our webinar today, we'll explore in more detail, what is a resilient building? How should cities and communities think about protecting their essential and critical assets? And to bring it to light, we'll also feature some case studies from some recent projects with Seattle City Light, developing resilient power systems, and then, of course, social equity. How do we protect our most vulnerable populations in our communities through the lens of multifamily and through the lens of community engagement. And finally, as Grace mentioned, we'll be doing the Q&A, but I encourage you all to type your questions as we go. And I know that we want to hold most questions to the end, but if there are some applicable questions, we might try to address them through the presentation. So quick word for those of you who don't know DNVGL, we are a global climate and sustainability consulting firm helping to make buildings and communities better prepared for the future. And our services include, vulnerability mapping and climate hazards, but really our focus is on buildings and energy systems, high-performance buildings, zero-net carbon buildings, and how do those concepts relate to resilience and relate to emergency preparedness, as well as distributed energy resources. So just to set the stage a little bit before Lauren comes on, we know that cities are really grappling with myriad aspects related to climate planning. And at DNVGL, we've supported cities for a long time related to mitigation and climate action plans and greenhouse gas accounting. But of course, increasingly, we need to look at adaptation and resilience given the projected climate change that's already happening. And so today we want to dive deeper into resilience at the building level, what I've seen is that a lot of cities have completed their adaptation plans or doing the vulnerability mapping of critical assets, but very few people are going into the building and assessing the resilience of these structures for their intended purpose, whether or not as an emergency shelter or as a place of refuge or, shelter-in-place type of approach. And then, of course, on the private sector side, business continuity and, being able to come back online as soon as possible. So those are some of the topics that we wanted to tee up and engage with cities in thinking about building resilience or resilience at the building scale as a next step in climate planning. So with that, I'll turn it over to Lauren to talk a little bit more about what is a resilient building.
Thanks, Betty. Hi, everyone. I'm Lauren Timor. And cities are beginning to take some of those more proactive steps towards resilient buildings. For example, investing in urban emergency microgrids, as Corey's going to talk about later, strengthening social cohesion in neighborhoods, and working to harden their physical assets. Some of you may have seen this statistic thrown around that $1 spent on mitigation saves an average of $4 in damages. In this statistic, recent studies have shown that this may be underestimated. So they're actually seeing that $1 spent on mitigation may save an average of $6 in damages. And where these updated numbers come from is Florida. So Florida's been hit really hard by hurricanes recently and in the past. And actually, after Hurricane Andrew, Florida took a look at their building codes. They found that the lax building codes were causing a lot of devastation. And so they implemented more stringent codes, which included requiring new or retrofitted homes to have hurricane-resistant doors and windows, as well as standing seam metal roofs. And a recent study after Hurricane Irma showed that they actually were able to avoid losses. So every $6 invested, every additional dollar spent on construction yielded $6 in avoided losses and reduced their hurricane-related insurance losses by 72%. So it's a really strong case for why making these investments in resilience pays off. Kind of jumping to the end a little bit, the future vision. What does this climate-ready building and community look like? So one of the things is, elevating mechanical systems, using passive strategies like enhanced daylighting and natural ventilation, community centers that have these urban emergency microgrids, using solar power and backup battery sources to enhance the reliability of power to the building. And then also investing in green infrastructure, so things like living shorelines and urban tree canopies, which can help reduce stormwater runoff as well as reduce that urban heat island effect. Reducing the impact of heat-related events. So this is kind of looking to the future. What do we want our buildings and communities to look like to protect them? Then taking a step back, how do we get there? So as Betty mentioned, we found that there's a lot of work being done to understand what the vulnerability is in cities and kind of within the community, and also on the new construction side. So we wanted to find a way to help building owners and cities understand what the risk was to their existing building assets. So with this in mind, we developed our Be Ready Building Resilience Assessment tool. Kind of three key goals. The first was we wanted to help simplify the process. So the way Be Ready works is to distill resilience best practices into site-specific recommendations that are relevant to each building. So understanding what those climate-related hazards are to the building, and then finding the best and most proactive ways to take action to reduce risk at the building level. The second is to provide a benchmark. So cities and portfolio building managers, they have a lot of assets, and it's hard to figure out where to prioritize their investments. And so the benchmark allows building owners to understand, which buildings have the most risk and where they should prioritize their investments first. It also allows them to kind of track progress over time. So, similar to like an Energy Star score and other ways of benchmarking buildings, this is a way to benchmark buildings for their resilience to climate-related hazards. And then the third aspect, which Betty touched on as well, is the vulnerable populations. And so in our work in multifamily housing, we realized we really needed to be more holistic in our approach to assessing building systems. We couldn't just assess, the building envelope and structure. We also needed to look at the occupants within the building and understand how they are prepared to respond to these types of events. So in the initial process, our approach to assessing resilience first is looking at that portfolio of buildings and figuring out which ones to assess. maybe you're not going to assess all the buildings at first, but figuring out where to prioritize based on the climate hazards. So taking initial data, oftentimes this comes from vulnerability assessments cities have already done, or other publicly available data like CalAdapt, and then pulling that in to do some hazard mapping, look at the buildings, consider other characteristics of the building in order to select the sites to assess further. And then we go into the data collection. So the first piece of that is a facility manager and building engineer interview. And the purpose of this is to understand the operations of the building. So how does this building function, during normal conditions as well as during extreme events? So they have plans and procedures in place to respond to different climate events. And then we go on site to the building and do a site visit. And this is really similar to an energy audit. So we're going through the building, looking at what building systems are in place. But again, we're not just looking at, current building conditions. We're thinking about how are these building systems going to respond during an emergency event, during some kind of climatic natural hazard. And then the third piece of data collection is that occupant engagement. So really talking with the community members, talking with tenants of the building to understand their level of preparedness. Do they have their own individual plans beyond the building plans? Are they aware of how the building can support them during an emergency? And then we take all this information and we input it into the Be Ready tool to run the analysis. And what this analysis does is we provide, the areas of most opportunity for improvement. So we have an understanding of the building's current resilience, and then where to focus those initial investments, and then maybe prioritize some longer-term investments down the road. So going back to that hazard mapping stage, so as I mentioned, we're really pulling in the existing data. We're building upon a lot of the work that cities have already done in vulnerability mapping. So for example, in New York City, we were able to use some of the One New York City hazard data that they've already done. They did a lot of great work around understanding the heat vulnerability of their index of their city as well as the flooding. And so we're able to use that data and then layering in the building's information in order to do this analysis. Similar with some municipal pilots we've done here in California, we're able to use CalAdapt data as well as any additional city-specific data and further analysis that they've done. And then what you see here is the climatic event matrix. So we're looking at those climatic events, which are on the left-hand side of the screen. And that's that information that we have available about the frequency and intensity of these types of events. But we're not actually concerned about those events when we're looking at the building. We're looking at the impact to the building. So across the top, we have the different hazard types. And this is essentially how these different climatic events will impact a building. So for example, when there's an earthquake, we're not concerned about the earthquake to the building. We're concerned about the seismic damage to the building, the potential power disruption and how that will impact the rest of the building systems, as well as the possibility of fire and other water supply disruption, other disruptions to the building system. So that's kind of how we take it from that vulnerability assessment down to the building level. So once we have an understanding of the hazards to the building, then we're going back to this data gathering process. And so when we're doing the building manager interviews, again, this is really trying to understand that basic information about how the building functions. And within that, we're also trying to understand kind of the key needs of the building. So different building types are going to have different requirements in terms of hours of operation, how long they need to maintain habitability. For example, do they need to be able to keep residents there, shelter in place, or do they just want to be able to come back quickly and then maintain their business continuity? So looking at what are the key needs of this building when it comes to resilience, and then how does it function? Do they have the plans and procedures in place, for an emergency as well as after a disaster? And then in that site visit, we're going through all of those areas of the building, walking through, looking at kind of three key things. So the first is this area prepared for an event? Second is, how would this area be affected during an event? So again, when we're looking at the systems, we're not just trying to see what type of mechanical equipment is in the building, but where is it located? Is it above the design flood elevation if flooding is a concern? And those kind of additional aspects that are going beyond an energy audit. And then the third is, how would this area recover from event? And then when we do that occupant engagement, we're kind of looking at the same thing. We're trying to understand how prepared is the community to respond to a disaster event, and how would they recover from it? Do they have some of those key social resilience things that will help them bond together as a community and support each other through the event. And what we found when we're talking with, the community of the building or the building manager and facility engineer is that people remember their experiences best. So the way we have these conversations is not through going through a checklist, but having scenario discussions. So we pose different questions to try to understand how the building is going to operate during these conditions. First, we like to think about, what has the building experienced? They've probably been through some kind of event. Maybe it's a power outage, maybe they had some extreme winds, and talking through what happened to the building during that event in order to understand where the biggest concerns are. And that also helps us understand how they respond, what types of plans and procedures they have in place. And then when they haven't experienced those events, we also kind of pose it as a hypothetical. So if there was a heat wave, what would you be concerned about? Would you be concerned about maintaining habitability of the building if the power shut down? Do you have some kind of natural ventilation in place that would help you keep airflow, or would you have to evacuate the building because it has no operable windows and it would get really hot and stuffy quickly? So this kind of helps them think about, okay, if I was in this situation, how would I respond and how would the building respond? And when we're doing these interviews, as well as when we're going through the building, we're really looking at it at a system level. So the information in the tool is organized by the building system so that we can help organize those measures to respond to. So we're looking at how will each of these different building systems, so the envelope and structure versus the plumbing, the site, how are they going to respond to an extreme event? And this is one of the outputs of the tool. So what we're doing here is taking all that information, running that analysis, and then understanding where the biggest vulnerabilities lie. So for this building, they have a pretty strong fire suppression and HVAC systems. They're fairly resilient to the hazards they face. But what we see is that their energy generation and storage capacity to respond to these events is fairly low, as well as their community. And so those are areas that should be targeted for improved resilience. And then this is looking at it from a different lens. So we're able to not only see the resilience of the building by building system, but also looking at how resilient the building is to different events. So this is that same building, but we're here looking at the resilience to climatic events. So you can see that their resilience to heat waves and wildfires is relatively low compared to their resilience to drought and windstorms. So again, that's kind of a different way of looking at where the vulnerabilities in this building lie. And the output of the Be Ready tool, as I mentioned, also provides a resilience index. So we're able to look at it on these different levels, the building system, the building hazards, as well as an overall 1 to 100 index that's based on the cumulative risk of the impacts of the climate-related events, as well as the capacity of the building to respond to those events. So taking into account kind of those three factors we've seen, which was the hazard frequency, so how often these events are going to occur, and then the consequence, so how bad will it be when these events occur, and then all that information we gathered through the building data collection to understand what the capacity of the building is to respond to those events. Then when we're looking at, what can the building manager do to take action, we want to break those recommendations down into 3 categories. So the first is capital investments, and those are those high-cost items that will need to be rolled into budgeting. The second is labor investment, so things that a building engineer can do or plans they can create that will require time but not necessarily be a high-cost measure. And then there's the social side, so the strategies that can help occupants prepare for these events and create awareness around them. And so one of the things that we saw through some of the municipal pilots that we've done was that a critical weakness in many facilities is in reliable, clean backup power. And this is especially critical when we're looking at low, middle-income residential facilities because they often have a high proportion of vulnerable residents that rely on power for, systems like elevators if they have, mobility challenges and need to evacuate, perhaps medical equipment. And so this is a really key area that needs to be addressed. Cora is going to talk about an example of that a little bit later. And so kind of on that same note, thinking about, that overlap between energy and resilience, one of the reasons that we focus on this is because there's a lot more funding available for energy efficiency programs and implementing energy efficiency measures than there is for resilience measures right now. And so we wanted to see, is there a way that we can capitalize on that available funding, things like energy efficiency, audit, and rebate programs, in order to make the buildings both more energy efficient and resilient. And so later I'm going to talk about one of our pilots trying to incorporate resilience into an energy efficiency program, but I want to just touch on a couple of the key overlaps here. So one is within that improved insulation. And so doing things like increasing the R value of insulation or thermal barriers, that helps to not only reduce the energy load of the building, but it also makes the building more resilient and improves occupant comfort during an extreme temperature event. Passive strategies like natural ventilation and daylighting, they also contribute to that energy performance of the building while also helping it maintain habitability if there's a power outage. And so, we're going to open up for a poll now before I hand over to my colleague, Corey. So we wanted to just take a moment after we've gone through this process and get an understanding of, would this type of assessment be useful to you? So you'll see on the right-hand side of your screen, the poll is open, and please go ahead and enter your responses.
It looks like we're getting up there. I have 50, 60, 70% voted.
Oh, great. Okay, so now I'm going to hand it over to my colleague, Cora Gesser, and she's going to talk about a project that's really at that intersection of renewable power generation and resilience.
Cora, are you there?
I am here. Hello, everyone. This is Cora Gesser. I work, as noted, with Betty and Lauren, and I lead our owner's engineering team, and we work pretty regularly with developers and utilities to help them through the procurement process of installing microgrids, rooftop solar PV, wind generation, any sorts of renewable energy generation that they are interested in to increase grid resiliency. So I'm going to see now if I've got opportunity to move the slides. There we go. I think I do. So as noted, I'm the project manager on our side for Seattle City Lights Microgrid for Resilience. I'm going to talk a little bit about how that project came to be, what it looks like, what some of the main goals are for Seattle City Light, and also some of the challenges that they've had in this pilot project. It's about a 3-year undertaking, and we're about a little bit under halfway through now, so we've already got quite a few good lessons learned with the city, and looking forward to having the microgrid installed about this time next year. So the City of Seattle was one of 5 Washington state utilities that received a grant under the Clean Energy Fund, which is a Washington Department of Commerce fund. In 2016, they distributed a little over $12 million to 5 separate Washington utilities in an effort to give them a boost, and oftentimes kind of matching with other funds that they have, to increase both grid resiliency and give them some opportunity to implement some renewable energy projects. So you can see here, this is kind of the landscape up in Washington. These are some of the major utilities, and the one, of course, I'll be talking about here is for Seattle City Lights. All of these folks here have some level of grid resiliency included in these projects, whether that's augmenting with energy storage, including a microgrid to create islanding capabilities. Lots of creative ideas came out of this, and kind of lots of interesting stuff happening under this Clean Energy Fund. So a little bit about the project. It is to be installed at a community center, the Miller Community Center, which is in the heart of downtown Seattle. I'm going to get a little bit into how that site was selected, but at a very high level, the city came to us with this idea that they wanted to select a site not only that was technically appropriate and would sort of best work with the existing infrastructure there, but also would maximize positive community impact. So one of the many factors that we were looking at in selecting the site was ensuring that this was an area that would serve a low and middle income population in the face of a natural disaster. Up in the Pacific Northwest, much like in California, the kinds of things we're thinking about are usually completely unpredictable events like volcanic eruptions, earthquakes. They were thinking about some of those major outages in addition to the more common, wintertime storms that we deal with. So their primary use case and goal was to have a microgrid located in an area and ensure that electric power is maintained during some periods of extended grid outage. The first piece of I guess the first part of the discussion I'll want to have here is just how complex this was to get off the ground from a stakeholder perspective. As you can imagine, not only was this the first, what they're calling technology innovation project within the city, Seattle City Light is a municipal utility, so they're a city department, but they did have to go through all of the same sort of processes and procedures that any third party would have to go to. Additionally, they had a ton of stakeholders, right? So the Seattle Department of Parks and Rec actually owns the community center site. So they had to work carefully with that host site, certainly with the city council, Office of Emergency Management, the fire department, all the other internal city light divisions on the right sort of contracting and procurement structure to move forward with this project. So they hired us as their owner's engineer, primarily to help them through what they expected to be a pretty hands-on, complex project the first time around with this microgrid, and the hope is that they will be able to replicate this and install other microgrids across the city as time goes on and kind of create a streamlined process to move this through. So at a very high level, here's the sort of schedule we went through. We engaged with them October of last year, and we did a site walk to look at several sites, several community centers that they were considering. We helped them estimate the building loads, both under normal conditions and emergency conditions, to get an idea of what kind of power supply they would need. And then right before Christmas last year, we helped them do a kind of multi-criteria site analysis and down selection to settle on a single site. And as I noted, there were a number of things we took into account there, which I'll talk about in some future slides, both technical, space constraints, grant requirements, and then also socioeconomic factors. Earlier this year, we then presented them with kind of a conceptual design, about a 30% level, that they were then able to integrate into their RFP to try and go find a vendor to build this out for them. We also gave them a high-level idea of CapEx, capital expenses, and operating expenses, and what we thought it would take in terms of timing to get the project built. We drafted their technical specifications. So this is basically the minimum technical requirements for the system and how it must interface with Seattle City Light's grid for them earlier this summer. And they published their RFP at the end of the summer, and we are currently in the process of receiving bids from vendors to build out the project. I'll get into the later stages in just a moment here. So this is a Google Earth view of what the community center looks like. When we were first evaluating the site, one of the things we were looking for is an area that had some usable area around it so that we could consider potentially ground mount PV, so that there would be space for people to come to the community center and stay in the event of a long-term outage, an area that wasn't heavily shaded by trees, and so that solar PV could be utilized, and then areas where a battery could be safely positioned to be sort of separated from the public and maintain kind of the safety concerns that the host site had. So we considered a number of things. We looked into solar carport PV, so the idea of having photovoltaic panels on top of a parking structure. That's often a great use of space when space is constrained, and in this case it ended up being a fairly costly option. So we ended up recommending moving forward with rooftop solar PV on top of basically on top of the gymnasium. We had to do kind of a structural analysis of the building to make sure that it could use that area. And then we also did some analysis to decide what would be the best place to site the battery. The city did elect to go entirely carbon-free on this project. So while they could have integrated a diesel generator, they chose not to, and are moving forward with just solar PV and a battery. So we were needing to find an area, like I said, that was separated from the public, that the host site was happy with, that could be constrained. And we considered a few different areas for where we would do that in our conceptual design. So in the end, we settled on about a 40 to 50 kilowatt PV array on the roof, as well as a 250 kilowatt battery. All of these requirements were, along with sort of the city's minimum technical requirements, were put into a detailed technical RFP that went out at the end of the summer. And the city is allowing a fair amount of creativity, opening it up for vendors to come to them with creative solutions for how they might meet the basic use case, which is to provide islanded power for at least 16 hours. Actually, I'm going to go back one slide here because there was one other thing I was going to say, if I can. The future things that we're going to be looking at here is obviously we'll be selecting bidders. Through early next spring, we're going to be supporting the city by reviewing the iterated design, so the 50, 90% designs and the issued for construction designs that come out of the eventual bidder. We'll be standing beside them during construction monitoring, so we'll be able to support as the project is built out, help with permitting, help with all the things that come along with a new construction project for the city. We'll be there to witness the commissioning and ensure that all the commissioning is in line with the warranties and the requirements by the vendors. And then perhaps most importantly, one thing that the city added to the scope of the vendor, which I think is really important, is an option for the vendor to train the city itself how to operate the microgrid system. So they've asked their vendors to provide an option either to pay for the city to be able to pay the vendor to operate the system for them, or for them to train the city so that they can operate the system going forward, and presumably they can do the same for any other systems they might install. And all of that is intended to be completed by mid to end of 2020. So it's about a 3-year process for the first one. I think that's quite good. And certainly the hope is down the line as well, as they repeat this, they'll be able to come up with a bit of a process in the system and generally increase resiliency across the grid. I think that is it for me, Lauren.
Okay, great. This is Betty. I'll introduce our next poll question here. Let me get it launched. Yeah, how interested is your city in solar plus storage or microgrid type projects? I think voting is now open.
Great. Well, while you're voting, I'm just going to introduce our next subject. So as Corey mentioned, one of the key considerations in choosing the site for the Seattle City Light microgrid was serving a low-income population. And social equity and addressing the disproportionate impact on vulnerable populations is a really important aspect of resilience planning, and especially when it comes to assessing resilient buildings. Particularly in multifamily housing, this is an important aspect of resilience and addressing social equity because of the displacement of residents during natural disasters. I'm going to share 2 examples of programmatic approaches to assessing resilience in multifamily housing. One is in New York City, and the other is in Sonoma County, California. So in Sonoma County, California, we are running a pilot program with Stop Waste and the Association for Energy Affordability to incorporate resilience assessments into Stop Waste's existing multifamily energy efficiency program. And the way this program is working is that we trained the Association for Energy Affordability's energy auditors on how to incorporate resilience into their existing audit process, so that we're really capitalizing on this existing program and process for assessing buildings and just adding in some additional considerations that they should be looking at when they're already assessing the building to try to make a more streamlined resilience and energy efficiency program. So we're looking at 5 pilot sites in Sonoma County, all multifamily buildings. They have different characteristics. So some of them are affordable housing. There's also senior facilities, and then just more traditional multifamily buildings. And the goal of this program is really to understand, can we use energy efficiency programs to increase more resilience, as well as can we use resilience as a driver to get people to invest in more of these energy efficiency measures, which help to mitigate climate change. And the second project I'm going to talk about is a pilot resilience program for the New York City Housing Authority. So we're assessing 10 buildings across our portfolio of more than 300 developments. The project is funded and supported by NYSERDA, the New York State Energy and Research Development Authority. And the overall goal of this project is to better understand how to address resilience in low-income multifamily housing because these populations are disproportionately impacted by natural disasters. And so when we started this project, as I mentioned, they had over 300 developments, and we wanted to narrow that down to 10 sites. So we use a GIS-based tool we have in-house called CView in order to layer those existing vulnerability assessments that New York City has already done with the NYCHA developments in order to understand the risks of these buildings and pick the 10 sites to assess. So this layer here is the Key Vulnerability Index. And then adding on, just to show you sort of how the tool works, we're able to layer on, for example here, the New York City flood risk in 2050 under 4 different sea level rise scenarios. And then adding in, the really future-looking capabilities, so looking at flood risk in 2100, again, under those same 4 different sea level rise scenarios. And what's nice about this tool is it allows us to have a really granular look, kind of seeing block by block the differences in the impacts of these hazards. And when doing this hazard assessment and portfolio site selection for NYCHA, we looked at not only the natural hazards, but also the characteristics and the demographics of the building in order to choose the 10 sites. So in terms of building characteristics, we wanted to look at, picking some representative buildings so that these strategies could be applied more broadly to the portfolio. And then in terms of demographics, we wanted to consider how the characteristics of the building population would be affected by these different events. So for example, you see here in the dark purple area, that's a really high heat vulnerability zone. And there's many buildings within that zone. So then we looked at, okay, what about the occupants of the building? And wanted to select the buildings that have, say, a high proportion of elderly in those high heat vulnerability zones, as they're going to be more sensitive to the impacts of heat-related events. So demographics play a really key role in assessing and understanding the resilience of existing buildings. And we felt that it was really important to assess the social systems of the building as one of the building systems, because it's particularly important with these low-income and vulnerable populations to understand their demographics, understand their capacity to respond to the event. So in order to better understand the social equity considerations and to develop a more holistic assessment of resilience for low-income communities, we used a 2-pronged strategy. The first thing we did was hold a stakeholder engagement workshop to try to better understand what the root causes of some of these core challenges were. And then we went and we connected directly with the community. And we wanted to do this for 3 main reasons. The first was we wanted to solicit their feedback on what we thought some of the core challenges were. It's one thing for us to go and say, oh, we figured out what your challenges are, but it's another thing to actually hear from the community and see, what do they think are the reasons that they're not using some of the services available, for example, limited use of cooling shelters. Why is that? The second was we wanted to use the workshops to create awareness, to help educate them about these events and inspire action to help them prepare. And then the third was we also wanted to use the workshops in order to assess their current level of resilience. So through these stakeholder engagement workshops, we posed core problems and then tried to think through sort of a root cause analysis. So for example, thinking about the core problem that residents of low and middle income communities are disproportionately affected by the impacts of heat-related emergency events, which will be exacerbated by climate change. So first we asked stakeholders to think about the direct causes. And here's what we heard. A lot of it is that there's equipment failure, poor building egress, and a lack of preparedness in a lot of these buildings. We also found, as I mentioned, that low use of emergency facilities like cooling shelters. So that was useful information, but we needed to know, why is this happening? Then we went and we looked at the underlying causes. We found that a lot of times the systems were poorly maintained. There was poor communication and sometimes a lack of multilingual communications in buildings that have a very diverse population. And also sometimes there's distrust of authority figures and people were afraid to seek help. So then diving deeper into those contributing factors, so what drives those underlying causes, we found poverty, low revenue streams for landlords often accounted for some of those challenges in keeping systems well maintained. Also a confusion between who was responsible for maintaining systems. So, sometimes tenants had air conditioning units and maybe it was already there when the tenant moved in, but the previous tenant had purchased it, so the landlord's not maintaining it, and there's some confusion around whose responsibility it is. Also, a lot of communities have, language barriers, immigration concerns, and lack of trust in public institutions. And so this kind of lends itself to some of the measures that we have developed to consider social equity in these communities, like establishing community champions who can be sort of that trusted figure within the community to relay this information. So based on our findings from these stakeholder engagement workshops, we went and we talked to the residents. And, as I mentioned, we wanted to hear from them, get their feedback, as well as to use the opportunity to assess their current level of resilience. And some of the critical things that we found were that resident awareness was very socially motivated, and it was also very tied to previous events. So in communities that experienced Hurricane Sandy very directly, there was a lot more awareness and preparedness in those areas. They had their emergency plans and perhaps a go bag, whereas if you go to a community that hasn't experienced a disaster event, they're less prepared. And so I think one of the key takeaways from that is that we really need to find ways to educate people before an event has occurred and not just after a disaster. And the second thing was found that tenant engagement was still really limited to specific motivated leaders in the community. And there's very limited reach to some of those socially isolated groups who may be the most vulnerable during these events. So increasing communication, both within the community itself as well as between community and management, was really important. And that's kind of, tying into, there's a really high dependence on management and these emergency services, and for instructions and understanding what's going on during an event, after an event, where are we supposed to go, when we'll be able to come back. So improving those communication channels is really critical. So based on what we found in the stakeholder engagement workshops, as well as connecting with the communities, we developed a set of resilience measures in order to assess the building's social systems as part of the resilience assessment. And I wanted to share kind of 3 of the key things that I think are really important for buildings, but also for cities. So the first, as I mentioned, because of that sometimes lack of trust for authority figures, it's really important to have empowered community champions. And these leaders can help prepare their community, reducing risk, improving services, and empowering their neighbors to adapt. And they're more likely to listen to someone who's a member of the community than, say, an authority figure. And the second is improving communication with tenants, especially having those multilingual communications. But beyond that, understanding the demographics of the residents is really important. And not only having, multilingual communications, but also understanding how the residents like to communicate. So, for example, in some of the pilots we've done, we found that some communities use Facebook very frequently. So, for example, they're often visiting the building's Facebook page to get information and updates. So that was a good way to communicate with the community to get information out. In other cases, they weren't very active on Facebook, but they had, say, a phone tree, or people used Nextdoor. So understanding how the residents of the buildings like to communicate and then using that to further improve the communication can be really valuable. And then the third is around having a strong social fabric. And one of the ways that this can be enhanced is having community spaces as well as community events that help increase the social capital that creates bonding and strengthens social ties. And it's been proven that during disasters, communities that have these strong ties fare better when they organically support each other. And this is something that can be done, not just at the building level, but also citywide. And so one example, an event that helps do this is Ciclavías in LA. It's a nonprofit that organizes days where the streets are closed down and encourage residents to get out to bike and walk. So not only are they encouraging these alternative active forms of transportation, but it's a way for people to get to know their neighbors beyond their own homes and really improve that social cohesion within the city. Kind of bringing it back to the core message here. As the frequency and intensity of extreme weather events is on the rise, investing in resilient buildings can add a lot of value to the community immediately. And buildings are a key asset for any city. They serve as a hub for emergency services, they provide community spaces, they house residents, and serve as places of work. So there's kind of 3 key things that come together: clean, resilient power supply, a strong social fabric, and resilient buildings. They come together to form the foundation of a resilient city. We're going to take one last poll before we open up for questions. So we're really interested in hearing from you now about what your key concerns or interests are related to resilience. And as we do that, I'm going to hand it back over to Grace for the Q&A.
Great, thank you. We have a couple questions here. Thank you so much to all the panelists for joining us, and thank you to everyone for submitting questions. The first one we have here is, what designing and operation targets and metrics are you using for overheating of buildings?
Okay, that's a very specific question. Okay, I think it's what design and operational targets and metrics.
Yeah, so what design and operation targets and metrics are you using for overheating of buildings? So, for example, they provided WBGT, set, and operational T, etc.
Yeah, I can take that one. So I think, there's kind of two things we're looking at here. We're not necessarily assessing like the overheating of the building per se in terms of, a specific level of, this is extreme temperature. We're more looking at like the temperature, the external temperature in terms of like when we're assessing the hazard. So we're looking at extreme heat days. So, days over like 101 degrees and the number of those to constitute a heat wave. And then in terms of, looking at the building, it's really about the strategies. So in terms of, having things like operable windows and passive, and ventilation. So I'm not sure if that fully answers the question, and I can follow up with some of the more, detailed sort of for each strategy, like where we get our limits, because we do have that. But in terms of overheating, we're really looking at like external temperature measurements.
Great. Thank you. And then this question is for Corey. Would the Seattle City Lights be willing to share its RFP for its microgrid?
That's a great question. I think they're willing to share it if you sign a non-disclosure agreement. So yes.
Great. And then in cities where existing vulnerability mapping and resilience assessment data is scarce or unavailable, what does data collection at the portfolio level look like?
Yeah, so, we have some global data. It's at like a 25 kilometer by 25 kilometer scale. So what we've done is taken, global data and then downscaled it to that level. And so that could be used, if there's not a lot of city level data. Depending, as I said, we kind of use the most granular data available. So if there's state level data, we can use that. And essentially, how that process works for the downscaling of data is we're taking historical data and then running it through climate models to project out for the future. So that's what could be done if there's not a lot of that at the city level, is using that higher level historical data and then projecting out. And then in terms of, the other data collection, one of the things we do is we want to find out what's happened at a building level. And one of the reasons for that is because sometimes there are events that occur that are not going to be captured in hazard data. So if you have, say a city that there's a certain street where the storm drain has gotten clogged up before and buildings have experienced flooding in an area that you wouldn't otherwise experience flooding. So that's where we like to also, talk to the building owners and see what's happened historically in their area. So I would say those two.
Great, thank you. And then the next question we have is, how far out in time are you doing the risk assessment?
Yeah, so I think, a lot of people are looking out to like 2030 or 2050 as kind of two different time horizons, but we can go out further. So, looking to 2100 if that's of interest as well. So the way we set the time horizons is really dependent on the interest of the client and if they want to just look at current versus future and, looking at potentially different time horizons to help them plan out.
And then Grace, I see another question here that popped up around cost. Can you mention some of the cost ranges for the pilot projects? So I think for the Be Ready assessments, I don't know, I think like on a per building basis, it depends on how much of the vulnerability mapping needs to be done. But I think it could be as little as, a couple $1,000s per building. Of course, that also depends on like the size of the building. And I will say that one thing that we're exploring is a licensing model. And that's something we've heard from some cities that they have like a Civic Spark fellow or Climate Corps fellow, and that's the model that we're using with Stop Waste, where we provide the data collection sheet, and then the fellow or the kind of auditor will go out and collect the information and send it back to us, and then we crunch the numbers and issue the report. So, there are a couple of different approaches to that. So hopefully that answers that question.
Great. And then the last one I have here is in your multifamily brochure, you recommend backup power. How does Be Ready assess adaptation by energy efficiency measures in buildings? For example, passive efficiency measures and microgrids.
Yeah, so, I think mentioned a little bit some of those links with energy efficiency, and essentially the way it works is we have a list of over 150 measures that are tied to different hazardous conditions. So for example, if we're looking at power disruption as something that could, impact the building, what we want to understand there is, how can the building prepare for a power outage? And so that's where things like, resilient backup power and microgrids can help mitigate the risk of that. And so similarly with some of the other, measures and strategies, it's essentially tied to what is the risk to the building and how can the building prepare to deal with that through those, different energy efficiency strategies.
Great. And are any of the tools that are part of the Be Ready assessment available to be used independently?
So yeah, I think, I think that's where the licensing model comes in, where we can provide the data collection sheet, or the checklist as well. So there are pieces that we could certainly pull out for that assessment to be done independently. Not necessarily by DNVGL. We're happy to provide, to license parts of the Be Ready assessment tool to others. And it is looking like that might be the most cost-effective approach rather than, having Lauren or one of our other engineers go out to the field. If you have somebody who's, like maybe your facility manager could fill out the form and fill out the questionnaire and send it back. And so those are some different models that we're exploring at this time.
Great, and I think that's all of our questions. Thank you to all of our panelists for joining us today for this webinar, and thank you to everyone who was able to participate. We hope you found it worthwhile and valuable. As a reminder, the webinar recording and PowerPoint presentations will be shared via email by the end of the week and also posted on the LGSCC website. If you have any additional questions for our speakers today, please don't hesitate to reach out. And now I'm going to turn it over to Margaret, who's the program manager for LGSCC.
Great, thank you, Grace, and thank you so much, Lauren, Betty, and Corey. We appreciate the expertise that you've shared with us this morning and look forward to continuing our relationship with DNVGL. Again, this is a program of the Local Government Sustainable Energy Coalition. We provide advocacy services and member and coalition networking and professional development and information exchange. If you are interested in becoming a member of the Local Government Sustainable Energy Coalition, please don't hesitate to reach out to myself or to Grace. One closing note, we are offering a program on October 25th. There is a forum in Santa Rosa titled Disasters and Energy Resilience, Keeping the Lights On in Our Darkest Hour. We hope you'll consider attending that forum. It's very closely related to this topic of our webinar today. Again, thank you everyone for attending, and thank you very much to our distinguished guests for their presentation today. That's all for now.
All right, thank you everyone. That concludes our webinar. We'll see you next time.